You can stall a wing at any speed, pointing straight at the ground, even in a dive. Here's the part almost everyone gets wrong about stalling. When we first learn to fly, it's easy to assume a stall is about pulling the nose too high, too steep against the horizon. It isn't. The wing has no idea where the horizon is. A stall is one thing only: exceeding the critical angle of attack. And angle of attack isn't measured against the horizon. It's measured against the air flowing over the wing, the angle between the wing's chord line and the relative airflow, the direction the air is actually meeting the leading edge. Think of your hand out of a car window. You tilt it relative to the wind rushing past, not relative to the road. Tilt it gently. The air flows smoothly over the top. Tilt it too far, the flow breaks away and tumbles. That breakaway is the stall. And notice it has nothing to do with how fast the car is going or which way the road is pointing. For most light aircraft, that breaking point is around 15 to 16 degrees between the wing and the oncoming air. Cross it, and the airflow separates from the upper surface. Lift falls away, drag piles on, and the wing stalls every time, at any speed, in any attitude. Here's the one that surprises people. Pull hard out of a dive. The nose is pointing at the ground well below the horizon, but you've swung the wing to meet the oncoming air at a steep angle. Exceed that critical angle, and it stalls. Nose down, diving, fast, and stalled. The wing doesn't care that you're pointing at the dirt. It only feels the air. So why do we talk about a stall speed? Because in steady 1G flight, you reach the critical angle at one predictable speed, but load the wing up a steep turn, an abrupt pull, and that speed climbs. The stall speed isn't fixed. The critical angle is. The wing always stalls at the same angle, it just gets there at different speeds. So remember, a stall is an angle, not a speed. The wing doesn't see the horizon, it only feels the air.